This is Algebra 2, Section 1.1. Before we begin, let's talk a little bit about learning through a video. If I go too fast, make sure that you hit that pause button, and then you can fill in your answer, and start it over again. Also know that you need to be actively involved in this video. So you need to be writing and thinking. Don't be texting or listening to another music or something in the background. You need to be involved in the video. I expect you to have everything that I write down on your notes at home. And if you're having a lot of trouble understanding, sometimes the best way to do it is to just sit back, watch the video once without writing anything, and then start it over again, and then write. That'll give you more of a big picture before you start. Okay, for our definitions, first you need to know what opposite is. In math, opposite is also called the additive inverse. And it's defined as the negative of any number. So the definition is the additive inverse, or the opposite of b, equals negative b. So the opposite of 4 would equal negative 4. The opposite of negative 5 would equal negative of negative 5. Clean up the signs, that would be positive 5. The reciprocal is the multiplicative inverse. This is defined as b is 1 over b. So the reciprocal of 3 would be 1/3. And the reciprocal of negative 1/4 would be positive 4. Now let's talk about groups of numbers. We have two main groups of numbers. We have real numbers and then imaginary numbers. Under the imaginary category, which you haven't worked with these yet, we have anything that has a square root of a negative 1 in it. Remember, the square root is what number times itself equals that. There is not any number that you can multiply by itself and get a negative 1. Because if we multiply 1 times 1, we get positive 1. And if we multiply negative 1 times negative 1, we get negative 1. So anything that would come out to be a square root of a negative 1 is an imaginary number. Under the real number category, we have two subsets. We have rational numbers and irrational numbers. That would go in these blanks up here. Rational and then irrational. And then under real numbers, or rational numbers, we have two more subsets. We have whole numbers, and then we have integers. The whole numbers are 0, 1, 2, 3. Integers are all those plus the negative whole numbers. Negative 1, negative 2, negative 3. Okay, well, what about irrational numbers? Irrational numbers cannot be written as quotients of integers. Remember, a quotient is a division problem. So if we can write a number that comes out to be the answer would be from a nice division problem, then it's an integer. So if we're trying to test whether 3 is an integer, I can put down 21 divided by 7, and that is 3. These are real numbers up here. So it's a rational number. But an irrational number we can't do that with. One of the most famous irrational numbers is the value of pi. One that you'll work with this year that you haven't yet is also the value e, which is kind of like pi in nature. A rational number can be written as decimals that terminate or repeating. You know that 1 divided by 3 is 0.3333 repeating. And that would be satisfy the results for a rational number. Irrational numbers can't do that. Like pi, you know, is about 3.14, but you know it never stops. It keeps going forever, never repeats, never stops. So that would be an irrational number. Most numbers that you'll work with are real and rational. Okay, example 1. Graph the real numbers, negative 13, 5 and square root of 6 on a number line. Well, when we divide out negative 13 over 5, we will get negative 2.6. So we go to negative 2 and a half, just a little bit more, and there it is. For square root of 6, we have to have a calculator to approximate square root of 6 to the nearest tenth. You learned this in your little kids' math classes, that remember square root of 4 is a pretty number, is 2. Square root of 9 is a pretty number, and is 3. So this would be 2 point something, because square root of 6 is between square root of 4 and square root of 9. So if we put that in our calculator, we would get 2.4. So we would come over here and not quite a half of the way. So to fill in our other blanks, we would put that one between negative 3 and negative 2, and that one between 2 and 3. Properties of addition and multiplication. Let A, B, and C be real numbers. And remember that a real number is not an imaginary number. Imaginary number is square root of negative 1. So these are real numbers. Now we have a property called closure, which means that if A and B is a real number, then if you can add them up and the answer will be a real number, or multiply them and the answer will be a real number. We don't actually use this property very often, so it's probably one of the least important. Commutative property we do use all the time. And here's an example. A plus B equals B plus A. What that means is 1 plus 2 equals 2 plus 1. It doesn't matter what order you add stuff in, numbers in. And under multiplication, it doesn't even matter what order you multiply real numbers in. A good way to remember the commutative property is I think about it as communicating. And if two people are having a conversation if one starts it and says something to the other person, to have a real conversation, the other person needs to turn around and say something back. So A plus B equals B plus A. Okay, associative. If you add two numbers and then you add a third number, it doesn't matter if you group the numbers a different way and add them together, it still gives you the same answer. In multiplying, A times B times C equals A times B, C. A good example of this is when you were younger. Let me move the screen over just a little bit and get some empty space to write on. When you were younger, you probably learned not to say 1 plus 2 is 3 plus 9 is 12. But you probably learned that it was easier to group the 1 and the 9 together to make 10, and then to go ahead and add the other number. And you always came out with the same answer, and it was a little easier to multiply. Last year in geometry, for the multiplicative associative property, you should have learned that for the area of a triangle, say the formula is 1/2 base times height. Say that base was like 7 and the height is 10. You could have, or you should have picked up on that it was easier to go ahead and multiply the half part times the 10 to get 5, and then multiply by the 7, instead of trying to figure out what a half of 7 is. Not that you couldn't, but it was just a lot faster to go ahead and regroup in a different way. The way I remember this property's name is I remember this by associatives, like business associatives. If A tells B something to do, B turns around and tells C something to do. So think about A's being the boss here and telling B, the middle management person, what to do. Then B turns around and tells C what to do. Business associatives. Okay, identity. Identity is, I remember about who we are. So we can add 0 to any number and it doesn't change its identity. We can also say 0 plus A equals A. Under multiplying, we can multiply anything by 1 and it doesn't change its identity. Either way, A plus 1, or A times 1, or 1 times A. That would be the identity property. Inverse, if we add the inverse, we get a 0. Or if we multiply by the inverse, we get a 1. The following property involves both addition and multiplication, the distributive property. You learned this in Algebra 1. We could go ahead and multiply A times B and then add A times C. This is an important property because in the order of operations, you learn to always do what's inside the parentheses first, but sometimes we don't have a choice. We can't add those together if one is a variable. So we do need to go ahead and multiply by the outside to simplify it. Okay, example 2. Identify the property that the statement illustrates. So if I have 6 times 3 and multiply that together to get 18, and then multiply by 2 to get 36, that's the same as saying 6 times and then multiply 3 times 2 together to get 6. 6 times 6 equals 36. So what is this word for this? If 6 tells 3 what to do, and 3 turns around and tells 2 what to do, this would be an example of the associative property. And then, which associative property? Is it addition or multiplication? Well, it is multiplication, of course. Okay, on B, if we have 21 and we add the opposite, negative 21, we get a 0. Which would this be? This would be the inverse property. And since we are adding, this is the inverse of the addition. Okay, on the checkpoints, I want you to go ahead and try these two on your own. Try very hard to get them right. We'll go ahead and look over them in class. So I think you'll be fine. Go ahead and stop the video here and then do these two checkpoints and then start them again when you're through. Okay, defining subtraction and division. Subtraction is defined as adding the opposite. So technically in algebra, we really don't talk about subtraction at all. We just talk about adding a negative. Okay. The second blank would be the opposite, or what was the other name for opposite? Additive, inverse of any number. B is negative b. B is positive, then negative b is negative. If b is negative, then negative b is a positive. So here's the definition of subtraction. And like I said, we just talk about it as being adding a negative. So division is defined as multiplying by the reciprocal. The reciprocal, or the multiplicative inverse of any non-zero number b is 1 over b. So if you are talking about 3 or a divided by b, say 3 divided by 1, we can also think about that as being a multiplication problem. 3 times 1 over 1. Okay? And that's the definition of division. Okay, for example 3, show that 9 plus parentheses b minus 9 parentheses equals b. Well, I could change this minus sign to a plus a negative. I haven't changed the value of that negative 9 any. Now I can flip it around to the front and put it here. And that's the commutative property. B talks to negative 9. Negative 9 can turn around and talk to b. Then I could change my grouping symbols and using the associative property. And then we know that 9 plus a negative 9 is 0 from the inverse property of addition. And then 0 for a b from the identity property is just a b. Now, this is a very complicated example of this. I really don't expect you to be able to do this just because it's not really necessary. So you don't have to finish the checkpoint at the bottom. Just go ahead and leave that blank. And that's the end of this video.